Hi, friends. Okay, let's start this video voltage. Okay, get my camera down, and here we go. All right, let's start with a chemistry reaction. So I have these two cups here. I put them like this, right up here, as so. Okay, now we're going to take a measuring cup here. All right, I'm going to shake this liquid that has the letter A on it and measure out a certain amount, 40 ml. So let's see. Okay, we're going to pour it right inside there. Now, we need another liquid, another solution. So I'm going to take another empty cup. I'll put this down for 1 sec right here. Take another cup, put it there. And now we're going to use the B liquid. So it's definitely not the same. So here we go. All right. I'll pour it in there. Okay. Now I'm going to mix those two together and let us see if there's any kind of change. All right, here we go. That's the second one. This is the first. All right, everybody ready? Let's take them, mix them together. Here we go. And keep watching for change. Here we go. Whoop. No change. Let's go again. No change. Let's pour it again. All right, we got to wait for a change over here. Let's keep watching. It's science. We don't know, but whoa, look at that. Wow. The question is, how did that happen? I don't know. Yes, I think I do know. Okay. Those two chemicals, the A and B, needed time to change. That's why in science we call that a clock reaction. So from a clear liquid to a purple. Now the question is, can I change this back to clear? But it's a science show and not a magic show. So I have to use science, meaning chemicals. SM, salt mixture. Let's see if this salt mixture can change that back. Yes. Okay. Going to put a little bit of salt on my hand, and I'll show it to you 1 second. Got to put the covers on. Here we go. So the salt is in my hand. Okay, let's put it in. Did it change? No. Let's mix it. And there you go. So the first one was a clock reaction, needed time. The second one was much more similar to spontaneous, didn't need much time. So very cool science, chemistry reactions. Okay, very good. So that's the science of chemistry. Now we're going to go to physics. In this cup, I have these beads, all right? And they're white, so we'll leave them here. Now, I'm going to take a little light, which I have over here. Put it on, and it works. So, let's expose those white beads to the light. Here they are white again. Put the light on, count to 5. 1, 2, 3, 4, 5, and look at this. They now change color. The reason is these beads are coated with a certain chemical that reacts to this UV light, ultraviolet light like the sun. And there you go. Pretty cool. I even have them in a test tube over here, pure white, but if I expose them to this light for a while, you're going to get those change in color. say they're going to actually change color. And it's all due to the response of the ultraviolet, like the sunlight, right? Like that. And eventually, they'll go back to clear because there's no ultraviolet light, usually with the indoor light. Okay, when you're outside, it's constantly ultraviolet light. All right, let's try yet. That's right, another experiment right here. A bottle with a pump. Now I'm going to pressurize this bottle and see if I can make a cloud appear. Let's see. Put it on. Let's see. Hear that pump? It's building up pressure. Building up pressure all the way, pressurizing the water inside this bottle. Okay. Then when I open it up, hopefully a cloud will appear. Pretty cool. All right, let's just go a little slower so we can see the steps. Here is that pump tube. And I had the bottle over here, and I had some water alcohol inside of it. And I'll get it again. It's right over here. I'll put some drops inside. 1, 2, 3, so you can see it. It's water with a little alcohol inside, but water works just fine. And the reason why this works, it's all about pressure. Okay. So here it is. When it's high pressure, you don't get the cloud. But when the pressure goes low, when I open it up, is when this cloud forms those droplets. Looks like a fog, which it is. So here we go again, putting the pressure all the way up. 20 psi, pounds per square inch. Here we go. So when I open it up, we should get that cloud. So here, fast 1, 3, and there you go. Cloud in a bottle. Just like how a real cloud does form. Amazing. Okay, very good, very good, very good, very good, and very good. So that's all about pressure. So we did chemistry and a little physics over here. Okay, now, fine, we'll try yet another one. Move this over here, and it's in this little jar here. See the jar? There's water inside. Okay, let's see what we can make happen with this experiment. Okay. Now we're going to take something here, a little hand, whatever. Okay. I'm going to open it up like that. Okay. In the water. Going to take this hand, reach inside the water, come up, and look at that. Water balls. Put them back inside, they're gone. Okay. Here we are again. Go inside. There you go. So these are so many different names. They were made basically in the beginning to grow plants. They're little beads that absorb water. So they're made up of 99% water. That's why when you put them in water, they're really hard to see, unless you go real super duper close. But that's how it works. So they're actually in the water, and when I just scoop them up, they come out. One is actually broken, and there I can remove it, and there you go. Pretty cool. Water beads. Diffraction, the way light prevents us from seeing it. But definitely a very, very cool experiment. Cover it back up. Save it for later. Okay. This was really some kind of a server for Halloween. I don't even know. was pretty cool. All right. Very nice. Put it back there and put that on top. Okay, now we have a bottle, a little piece of swiggly plastic. Okay. Now I'm going to take this bottle, even turn it upside down to show you there's nothing inside. You can see it. Pretty cool. Nothing in there. You hear anything? Nothing. So I took the bottle, I put it this way. All right. Now I'm going to turn it over and put this inside. Turn the whole thing over this way like that. Let it go. And it holds that piece of orange plastic. Even this way, it'll hold it. So how is that working? There's nothing in the bottle. Or was there something? And this is an experiment that you could try. That's right, at home. All right, watch how I did it. Okay, the answer is so simple. There was a little ball inside, but I had it in my hand. So when I showed it to you, it was empty. Okay? I put it this way. I just spoke loud so you couldn't hear the ball. Turned it over so the ball is inside. So when you put this stick in, turned it over, the ball comes down, gets stuck over here. You can see it. And actually holds it. Like that. And then when you're ready to give it to the person, you put it down, the ball drops, you go this way again. Before you give it to the person, the ball is in your hand, they won't see it, and there you go. So it's a science experiment that you can try at home with an empty bottle. Of course, it has to be not clear because you can't see the ball. Alcohol bottle peroxide. Any stick will work. Even a chopstick will try. And a rubber ball, or you could roll up aluminum foil. Here it is. Put the chopstick inside. Turn it this way. And there it is. The ball wedges inside. The stick hit this way, up, and there you go. How simple, but it does look like a magic trick, but really a science trick. So really cool. Very good. And it's science. Amazing. Okay. Here's really another one you could try at home. And it's hard to believe. Uncooked rice. That's right, uncooked rice. There's nothing else inside. You could even empty it, pour it, but, for time's sake, we don't know. Open it up. There's the rice. Put it there. Take your chopstick. The question is, can we, here, Vinny Volage, pick this up with the chopstick? All right, let's see. Put it in. Seems impossible. Put it inside again. Nothing. And again. You must think I'm crazy. Let's keep trying it. Just a chopstick and rice. Put it in again. Nothing. I want to pick it up because it's science. Again. What? This is a hint. Squeeze the bottle. Stick comes out. Amazing. Not really. Pure science. As you put the stick in, the rice is compressing. Compressing. And eventually, it grabs onto that stick, holding it inside. So it's just rice uncooked. A peanut butter jar works. Use plastic because it could fall, because it does pick it up, but not that much strength. So when you put it in, you're actually compressing it and holding it again. But when I relieve the pressure, it comes out really easy. Now, somebody thought, what about if the stick was really thin? Would it work? Now, look at this. Amazing. How's that for a thin stick? Would that lift it up that thin? Well, with science, and let's try it. No. No. I don't know. We're gonna try. We'll have to experiment. Keep going. I don't know. If it's a science experiment, it should work. Let's see. Because it's thin, it's definitely harder, but it'll show you how real it is if it does work. Amazing. I have to be careful because it could fall so easy. And if you squeeze it again, relieve the pressure, and right out. Something you can try at home. Amazing. Definitely an amazing experiment. It's so hard to believe, but you have to be careful because it doesn't grab on that hard to the stick, showing you that it's just the rice really holding it together. All right, very, very good and amazing. All right, let's try another chemistry experiment. Okay, let's take a test tube here. Just washed it out, but here it is. Okay. Drops. Not water, it's a chemical. We'll talk about that later. I think 10 drops. 1, 2, 3, 4, 5, 6. I can put more. Then to this, I'm going to add water. All right. Water. H2O water. There it is. I'm going to get some more water from the sink, so just follow me. I'm over here getting the water. All right, we're getting the water right over here. The water, okay. Get some more water needed later. It's water. Sink. Okay, here we go. The water. All right, so that's clear, meaning colorless. So put it over here. Put a cap on in case it falls. Shake it up. All right, another test tube. Here we go. The old test tube. Pretty cool. All right. Now, we're going to put something inside. Simply put soap. Here it is. In the dropper bottle, soap. Here we go. 1, 2, 3, 4, 5 drops of soap. And I just realized that this thing was not clean, so let me get another one. Okay, now to this, I'm going to add some water. Same amount about. Two clear liquids, right? So let me open this one up and this one, and let's mix them together. You guys ready? All right, watch. Aha. Some kind of pink color. Some people call it fuchsia. I don't know. Looks pink red to me. Question is, it's science, not magic. How'd that happen? Well, first chemical that I used, an indicator for soap. When it mixes with soap, you get pink color. Okay. Now, let me take some lemon juice over here. Lemon juice is in the classification of chemical that we call acid. Yes. All right. So we have smoke coming up over here. Sheesh. Tricky. All right. Okay. So we're going to open up the pink one. This was my lemon juice. There. Here we go. Whoop. Went back to clear. Because the lemon juice, a process called neutralizing, it changes that salt. No. It changes that soap into a salt. So it's no longer soap. So that's why we don't get the change, that color change. And there you go. Of course, you could change it back by adding more soap. So let's leave it like that, shake it. Definitely a clear liquid. So let's get some more soap and see if we get that change again or not. Experiment does tell us all. The experiment is everything. The reality is your experiment. Okay, here we go. Here we are. Whoop. It went for a second. We're going to try that again. All right, let's take the soap and change it red. Put it here. See that? When it mixes with the soap, it goes red. Okay. Cover it up. We'll lift it again to show you. And here we go. But this has the acid, and the acid is stronger. It'll actually change it back because there was enough acid to neutralize that soap. And there you go. Pure chemistry reaction. Very good. All right, let's go back to physics experiment. Here, just a case, but flashlight with a battery inside. It's not really a flashlight. I'll turn it on. You can see what it is. It's a little laser light. See that? Okay, so we're going to take it, leave it over here, the laser light right on top. We have a small little metal box with a piece of paper inside. Okay, opening it up, we're going to take one sheet of this paper out like this. And there is the paper. And you'll see the paper is black, gray, light black. Okay. We're going to shine the light onto this paper and see what does happen, if anything does happen. Okay. Here we go. Put it on. Shine it on the paper. Whoa. What? What happened? Amazing. I think it lit on fire. The question is, why? Why do we think that lit on fire? Well, there's a lot of reasons. First of all, the laser is kind of strong, not very strong, but strong enough to produce heat because it has a magnifying glass that focuses on it. The paper color is black. Black does, yes, absorb heat. Okay. And it was also chemically treated, that paper. Okay? All right, so let's try it again because it's kind of, you may have missed it the first time. Okay, guys. Here we go. Get a piece of that paper from this little can. Okay. Here it is. We'll close it up. There's that paper. All right. So once I focus that light on it, it produces heat. That, yes, lit it off. Definitely amazing. Amazing stuff. Good science stuff. Here it is. Here's the paper. We'll focus it. Whoa! That is incredible. So such a physics experiment, light, laser, amplified light, which a laser really is. Okay. That's why I leave it in this case. Of course, I take the batteries out of it. Keep it safe so no accidental ignition, which we don't want. All right, here it is. Put it back. You got it. Pretty cool. And there it is. Inside safe. Our laser. Okay. Good, 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 good. Very good. Now, Vinny Voltage, me, knows a lot about electricity. We have this small little module here. I think it's tiny. It's a battery. This thing comes from like a barbecue, a stove, or a heating system. It actually lights up the gas. Now, the battery is rated here at 3.7 volts. Not much, but this device is called a transformer. Step up, and it changes that voltage, the 3.7 volts, to 20,000 volts. This small, amazing science, but yet so useful. So let's turn it on and take a listen. Whoa. Amazing. But that's what physics, electronics can do. You know, if you really study it, it can actually change voltages. From that low, 3.7 is 3.7 is like for a cell phone. Approximately 3.7, I believe, a cell phone. Yes. And it makes that spark. That spark comes from it lights up particles in the air because the pressure is so high, and you get the collision, that noise. Amazing. Try it again. Now let's see if this could light up that paper that I had, that the laser did. It's different now. It's not the light that's doing it. This would be heat from the spark. Bombardment. Amazing. May take a little longer, but let's see, because we're science experimenting. So let's fold it up. We'll put it in the middle of the gap and see if that can actually do. Okay? Here we go. Ready? Not yet. Let me reposition it by holding it and try it again. All right, ready? Let's see. Oh. All right, be very careful with it. Let's see if it'll work today. No, it sounds so strong that I could light it, but it's definitely have a problem. Let's try one more time. But you saw that light was so concentrated, lit it up like it was nothing. And it was the same voltage, 3.7. Let's try it again. Let's see. So it did. Eventually, it does light it. Okay? So high voltage electricity. Really cool stuff. Let's shut that off so I don't shock myself by accident. Really, really cool experiments. Okay, we have a little time left, I think. We're on for almost 50 minutes so far. Okay, we did the experiment there. That one. Really, really cool. Okay, let's see what else I have here. moving this out of the way. Oh, here we go. Ah, stuck. Really stuck. What is going on? Okay, here we go. Pom-poms, right? Okay. We have blue, yellow, red, green. So if I pull the yellow one down, the green one goes up. Again, green down, yellow up. Green down, yellow up. Green down, yellow up. Green down. No, yellow down, green up. Green down, yellow up. Yellow down, green up. I'm getting confused over here. All right. So obviously, we all know there has to be a string inside to make this happen. Okay? But watch this. Very strange, but let's watch it. If I take the blue one and go up, watch. What? The other side's not moving. If I take the red one up, it moves now. But this side's not moving now. And the red up, and that way. Now I see what happened to the camera. Reversed. All right, don't worry, I'm learning everything. How is that possible? Look. I don't know. Again. And again. Do it this way, up, but now that moves, you're not moving the other side. It actually is making us think, how is this working? So I'll open it up, and I think I'll show you. You know there has to be a string. Come on. Both down. Let's open it up and show you. No string. There is no string. No string at all. No. Amazing. Put it back. Connected. I don't know, but it's got to be some kind of a string because look, if I move it now, it goes back up. Okay. Pretty cool. Any ideas? It's really simple, and it's science. It really is connected in the middle. I'll open it up. There's a magnet there, but I could pull it apart. See? They connect, and that's the answer. Purely amazing. But it's very tricky because everything's hidden. But definitely science. Okay, let's try one last one, guys, and we'll leave you. Vinny Voltage, was great having you with us today. Okay. And thanks to Magical Memories for having sponsored this very much. Great company, great people. I would definitely use them for any kind of advertisement, any events you have. Okay. All right, this over here. It's a tube, plastic tube. Going to take out can. If we tap this way, nothing. But if we tap this way, whoa, flower comes out. We're not magic. We're science. But magicians are really cool, though. But we're science, meaning we learn how things work. Because that's what science is, learning how things work. Okay. What this is, I made it was a feather duster. And I put a magnet on the bottom. See a little magnet on the bottom over there? Okay. And I had it inside the tube, just like that. Okay. So the magnet, I made sure, was on the end of it. So this is iron, has iron. It's stuck to it. So when I pulled it out, it was really attached to the bottom. It looks like it just comes out magically. But it's all science. Okay, friends. Very, very good. And there we go. Okay. Okay, guys, I want to thank you so very much for joining Vinny Voltage today. And we want to thank Magical Memories for sponsoring Vinny Voltage show. Okay? So we want to thank you so very, very much. And hopefully we'll see you again. If you ever need our services, just please contact Magical Memories. Okay, Vinny Voltage out. Thanks so very much, guys. It's great having you anytime.